Okay, everybody. So we did this on Friday, and so I thought I would do a quick video and kind of do a review over why cell specialization. So I'm going to do fat cells first. What's interesting about fat cells, I'm going to page down here until you can see the actual name. Again, the purpose of doing this assignment is to really talk about, okay, I want to cancel this. Is to look at how can we have all these cells? They all have the same parts, yet some parts are bigger or the cells are bigger, and what's the purpose? So with this one, I would jump right out and say this one is different because this one has a huge vacuole where all the fat is stored. Okay, function, structure is directly related to function. So this has a huge vacuole because it stores. So right here, it stores all this fat. So that's kind of cool, huh? Okay, I'm going to come back. How about nerve cells? Nerve cells are kind of interesting when you look at a nerve cell. So I'm looking at the pictures here. Here is a nerve cell right here. So you can see it has some of the same parts: nucleus, ribosomes, Golgi apparatus, mitochondria. But look at all these weird things here. Look at, and they're super long. So they're super long because they have communication that they have to do in between one neuron to the next neuron. So they have this super long cell body that's coming out for communication, kind of like tin can telephone, if you can imagine that. Muscle cells. This one, I'm going to go a little bit. Here's the muscle cell. So this is a cross section. So all of these right here, these muscle cells, these are all microfilaments. Now they call them myofibrils because they're in a muscle, but these are all microfilaments. Those are the actin and myosin that actually do the contracting part. Plus there's nuclei and lots of mitochondria because we need lots of energy. So why does it look like this? Because this cell is contracting. It's shortening and lengthening. That's part of its job. Intestinal cells. Those are kind of fun. Intestinal cells, I'll click on this picture, have these microvilli that actually help with absorbing material into the bloodstream, which is kind of cool. So see, these are the intestinal cells that line, and so they're helping absorb. So that's why these have these little finger-like projections coming off from the cell. See, here's the nucleus right here. So some of the same parts, again, look different because they have a different function. Respiratory tract looks very similar, except the respiratory tract, okay, has cilia. Okay, this is the cilia right here, and has these cells. Okay, there's nuclei right here. Okay, and it also has some mucus. So why would I want my respiratory tract having cilia on it? Because I want it to capture all the gunk and sweep it back out of my body. Okay, two of my favorites. The egg. Okay, egg cell. So, like I like to say, so the egg, here's the nucleus, here's mitochondria. The egg, us ladies like to put all of our cytoplasm in one egg, okay? So we have, this is huge. So think about it, that we actually are the ones kind of going to get the groceries. We have all the groceries. And the guys, well, with sperm, they just show up for dinner. The sperm has a very small head where most of it's taken up by nucleus. It does have mitochondria, so it can power this ginormous flagella. So if it has a flagella, that must mean that I'm swimming. But guys, don't think that your part in this is not important because you're bringing all the genetic information and you actually determine the sex of a child by giving either an X or a Y chromosome. Okay, last couple ones. I love the red blood cell. Red blood cells are pretty doggone cool. They are shaped kind of like a donut. And here's the thing, are you ready? It's not about what cell parts they do have, it's what they don't have. They don't have a nucleus. They don't have mitochondria. They don't have ribosomes. They don't have much of anything. because they need to have more room for carrying oxygen. And they're super, super small. Okay, so they can fit through all these capillaries in your body. This is what actually forms your blood. Isn't that cool? So it's more like what parts don't they have instead of what they do have. And a bone cell or an osteocyte, that's one of my favorites. I like to come down here. A bone cell here, I guess it's not gonna. The big thing about a bone cell, think about putting somebody in a vat of cement. A bone cell can't exist in a vat of cement. It's got to be able to do its cytoplasm. It's got to be able to bring things into the cell and out. So it has all these, like, it has a bunch of pipe pals. So it has these extensions off the cell that communicate with other cells. Here's a great example up here. See how these are through the cell? They all are communicating with one. So an osteocyte has pipe pals, pretty much. And those are processes. They still have all the cell parts. They have mitochondria, endoplasm, reticulum, all of those things. It's just that because the outside is all like hard bone, it's got to have areas where it can still do its cell thing. So if I were to bury somebody in cement, I'd have to put them in a barrel so they could still exist and do their thing and breathe, and put a pipe up to the top of the surface so they could still get air and granola bars and all that. And then you could sink somebody else in cement, and I could put a pipe between them so you could talk from one person to the next. So the big thing on all of this is cells are the way they are because their structure is directly related to function.